Okay, so in this lesson we're going to talk about factorising non-monic trinomials. What do we mean by non-monic? Well, our normal quadratic trinomial is set up in standard form like ax squared plus bx plus c. The number in front of the x squared is going to determine if it's monic or non-monic. Monic means that a is equal to 1. Non-monic, surprisingly, a is not equal to 1. For example, a could be 3. You might have 3x squared plus 2x plus 5. Because that's a 3, it's a non-monic trinomial. Before we factorise non-monic trinomials, let's have a look at grouping in pairs as a way of factorising. So here we have a pair and another pair. So we're going to factorise these two pairs separately. Factorising 8x squared and 12x, 4 and x both go into 8x and 12x. So I take 4x out. 4x times 2x equals 8x squared. 4x times 3 equals 12. So I've just factorised 8x squared plus 12x. What about 10x plus 15? Well, 5 goes into 10x and 5 goes into 15. 5 times 2x is 10x and 5 times 3 is 15. Okay, what's in common to this first term and this second term? What's in common is our 2x plus 3. So we factorise that out. Having taken 2x plus 3 out of this first term, we're left with 4x plus 5. So that's how we factorise by grouping in pairs. First factorise the first pair, then the second pair. Having done that, factorise your next line to get your final answer. The other day, we looked at area diagrams for something like 2x squared plus 13x plus 15. 2x squared, this area here, 2x by x. Now we could have 5 by 3 to create this 15 here in area. So the rest of the rectangle must make up the 13x. That and that equals 13x. Then we'll get our total area of 2x squared plus 13x plus 15. 2x squared, that should be 13x and 15. Also, it could look like 2x and x, and the 5 could be the long piece of this rectangle, and the 3 could be the short piece going that way. And we would get a rectangle much like that. So how do we know which of the two rectangles it is? Well, if that's 3 there, then that's 3 there. If that's 5 across there, then that's 5 across there. If that's x there, then that's x there. If that's 2x there, then that's 2x there. So I can see that that will be 5x and that will be 6x. Well, does 5x plus 6x add up to 13x? No. What about over here? If that's 3, then that's 3. If that's 5, then that's 5. If that's 2x, then that's 2x. If that's x, then that's x. That's 3x worth of area, 3 times x. And that's 5 times 2x, that's 10x. Does 10x plus 3x add up to 13x? Because this is 2x squared when you work out the area of that rectangle, and this is 15. So we have 2x squared plus 13x plus 15. Yep, that's what we want. So what have we discovered from this way of breaking up a trinomial into area rectangles, we've discovered that this one big rectangle here that's made up of 2x and 5 along the top and x and 3 going widthwise, that is 2x plus 5 times x plus 3, we've discovered that that doesn't equal to that area. Here, that length there of 2x and 3, 2x plus 3, and that down there of x and 5, x plus 5, makes this big rectangle, which does have a total area of 2x squared plus 13x plus 15. That is, the 2x plus 3 and the x plus 5 times together to actually equal 2x squared plus 13x plus 15. We have factorised it. So this gives the correct answer. In class, we were talking about an easier way than drawing up a diagram every time. And we came up with the method that when you have a non-monic, that is, a number in front of the x squared, you times together the first and last numbers, provided that it's set up like ax squared plus bx plus c. If it's set up in that form, you multiply together the a and the c. In this case, 6 times 12, which is 72. Now we need two numbers, I'll call them m and n, so that they multiply to be the number I just found. And they could be 6 and 12, but probably not. But two numbers at times to be 72, and they add to be the middle number, 17. This is very similar to our technique for factorising non-monic trinomials. The only difference being we're not multiplying to be 12 and adding to be 17. We're multiplying to be 72 and adding to be 17. So you need to go through your numbers and figure out what that could be. Now I can see that 9 times 8 is 72 and 9 plus 8 is 17, so my numbers are 9 and 8. Having achieved that, I'm going to split this middle term of 17x, I'm going to split it into 9x and 8x. That's why I did all this work. I've still got 6x squared for my original, and I've still got 12 out here. I just did this bunch of work here to figure out to split that 17 into 9x and 8x rather than 11x and 6x or 12x and 5x. How do you know how to split it? You go through this process. So we now have 6x squared plus 9x plus 8x plus 12. And we use the method of grouping in pairs to factorise. So what goes into 6x and 9x? 3x. 3x times 2x is 6x squared. 3x times 3 is 9x. What goes into 8x and 12? 4. 4 times 2x is 8x. 4 times 3 is 12. In common to this first thing and second thing is 2x plus 3. Having used the 2x plus 3 up, we're left with 3x plus 4. So we factorised 6x squared plus 17x plus 12x. Now you might ask, what if I had written 8x and 9x there instead of 9x and 8x? 6x squared plus 8x plus 9x plus 12. What if we'd written, well, we can still factorise by grouping in pairs. What goes into 6x squared and 8x? 2x into 3x plus 4. What goes into 9x? 12, 3 into 3x plus 4. Now 3x plus 4 is in common. Used it up, therefore I'm left with 2x plus 3. That's the same answer as I achieved doing it the other way around. 2x plus 3 and 3x plus 4 are being multiplied together. All right, let's have a go at a couple more. We'll speed up the process. Some people would look at this and go, oh, you've just told me how to factorise non-monics, and that's as a non-monic. So you're telling me that I should multiply the 4 and the 48 together and get some big number, 4 times 48. You're boggling my mind now. 192. What times is to be 192 and adds to be 28? This is not a very good method at all. But do remember that just because it's non-monic, it doesn't have to follow this. As with all factorising, the first overall thing you should look for is a common factor. Is there a number that goes into all three of these? Yes, there is. 4. 4 times x squared plus 4 times 7x plus 4 times 12. Now, I can easily factorise what's inside these brackets. What two numbers times to be 12 and add to be 7? 4 and 3. 4 times 3 is 12. 4 plus 3 is 7. Because it's because it's monic, there's a 1 in front of there, we simply find two numbers that times to be 12 and add to be 7. So that's easily factorised. One of the factors is 4. Be careful of that. If it's non-monic, see if you can take out a common factor first. Can I take a common factor out of here? No. 23 is a prime number for a start. So I'm going to have to split this 23x up. Sometimes you can just see the answer by inspection, but I'm going to go through the process. I'm going to multiply the 12 with the 10 to get 120. I'm going to search for two numbers, m and n, that multiply to 120 and that add to 23, this middle number. If I couldn't work them out, I could split up 120 into its prime factors. Doesn't matter which two things times to be 120. How about 3 times 40? How about that can be 20 times 2? How about that can be 4 times 5? How about that can be 2 times 2? So 3 and 2 and 2 and 5 and 2, those numbers all times together to give me my 120. So certain combinations are going to give me the factors I want. Now today, 3 and 5, 15, and 2, 2, 2 is 8. Today's one is 15 plus 8 is 23, and 15 times 8 is 120. So I'm going to need to split the 23x up into 15x and 8. 12x squared plus 15x plus 8x plus 10. Factorising the first two, I get 3x into 4x plus 5. And here I get 2 into 4x plus 5. So that'll be 4x plus 5 times 3x plus 2. Once again, what if I'd put these the other way around? Well, in this case, it's not going to be a problem. If it ever was a problem for you, for some reason, you can just swap them and make life easier. But in this case, what goes into 12x squared and 8x? 4x into 3x plus 2 plus 5 into 3x plus 2. So that's 3x plus 2 is in both of those, and 4x plus 5. Same answer. All right, if we're set up in this format, with the following expansions, what do you notice about this last number. So what I've done, I've expanded 3x plus 5 times 8x minus 7, and I got this. But what do you notice about that last number? I've expanded 2x minus 3 and 3x plus 4, but what do you notice about that last number? I've expanded x plus 1 and 4x plus 5. What do you notice about the last number? I've expanded. What do you notice? Yes, the two last numbers in the bracket multiply to be that last number. So sometimes you can see things by inspection. This one's actually not that simple. I've picked a more difficult one to do by inspection, because 6x squared could be x and 6x in the brackets, or 3x and 2x in the brackets. But one thing that I do know from the expansions that I've just done, since everything's positive, makes it easy, 13 will be in one bracket and 1 will be in the other. Now, I could just trial and error if I wanted. It's either 6x and x, or x and 6x, or 3x and 2x, or 2x and 3x. And generally, common sense will help you with such an inspection if that's required. So let's try 2x and 3x. If you put 3x in this one, 3x times 13 will be 39x. And you'll have another 2x later on, so that's going to be too many. If you put 2x in here, you'll get 2x times 13 is 26x and 3x. You know what? This was meant to be 29. Far out. Everything was going well until that situation, wasn't it? Let's say that's 29, and I hadn't messed up that by just making up one that's not going to be so nice. 3x, 39x, and 4x, and 2x is too many x's, but 26x's and 3x's is going to be okay. So I'm saying, through a bit of experimentation, that is not going to work. But that is going to work. Of course, it's always nice if someone gives you a question that's going to work out, if the question's written down properly out of your book. So always be careful if you have a set of exercises that you're actually attempting the correct question and you haven't put the wrong thing down.